So we're just going to do a check on whether water is actually hydrolyzed when you have metals that are too strong. So we're starting off with a neg control. So hydrolyzing water is very negative on both giving or taking electrons. It doesn't really want to do that. And so I set that up first. I'm using graphite electrodes here. You can also use platinum as inert electrodes. Platinum's going to work slightly better apparently because it's more of a catalyst. The transition metals, and it's giving a slight 0.01, which I'm going to write off as nothing. It's just not working, not giving a voltage reading. So the next one will be sort of a positive control check. I'm just trying to make sure it works when it's meant to. So I've got zinc here. The reactions are coming up in a second, but it was a little bit low. So I do a pos control check here. That was meant to be 1.1. It's not. Just get a battery that I know is 1.5. And you can see it's sort of obscured a little bit, but you can see a 1.5 pop up in the background, 1.47. So that is working. So there's nothing wrong there. So as I've said before, sometimes you just don't get enough voltage because of internal resistance. And same with electrolysis. Sometimes it won't work until you bump it up just a little bit more, up to 0.5 volts to get it to work. Or you lose 0.5 volts. So calculated as 1.1, only got 0.67, which is within, it's almost 0.5 volts. So that's how much less I get. And then some students get confused, like, what if you don't put the salt bridge in there? I was putting a very lousy salt bridge in there. And by the way, you can see the concentrations down on the left and right hand sides. They're sometimes not 1 molar. It typically just works way better if you don't use a salt bridge. And I leave that in there for a while and it doesn't really go down. So it's 0.8. So it is, 10% better without the salt bridge. You can see it's working because the copper's depositing directly on the zinc this time. And yet, you would think it's not going to, the electrons are not going to go in the right direction, but they are. So even with the instantaneous formation of copper on the outside, copper must still be forming and going around in the circuit because it's positive, and that's all there is for it to happen. Okay, so that's quite interesting. So just be aware. Obviously, we can't keep things clean, and you would think, it's dropped down to 0.82. I think it goes up to 0.83 again, though. You would think it would stop. And I think I've lost patience. Let's just say, that's long enough. All right, there you go. You can see copper there. All right, so we can just move on. So make a note of that as well. Okay, so you don't need the salt bridge. The salt bridge will keep it cleaner and possibly make it last longer. So jumping to what I was originally interested in is getting the water to hydrolyze. So magnesium and aluminium are the ones I'm choosing because they are above those red lines where the water is. So plus 2.37 should be enough to overcome the minus 0.83, so 1.54 volts. And it's pretty close. All right, there's only like 0.2, much better than the 0.4 something that was the copper. So it's much, much closer. I was hoping to see hydrogen bubbles come off and it become basic. So I put the universal indicator in. And I think realistically, it's just not strong enough because the only time you get bubbles off and you see the color change is when you hit it with like 15 volts. And I just don't think 1.3 is strong enough. It never works at 2 volts. It's just not strong enough. And if you do the calculations for hydrolysis of water, that wouldn't be strong enough. I don't think. It's about 2. And plus there's like a lot of homogeneous catalyst in there. There's like 0.1 or 1 molar acid. So it's just too slow. But the numbers show that it is actually working. And so if you go here to the aluminium, again, the numbers add up exactly the same. So it must be working. This is a platinum catalyst. Haven't put it in yet. So there's the aluminium strip and there's the platinum little curly bit at the end. All right. And that's giving the same reading. So you can see that a lot of things don't matter that much. That salt bridge is only like 0.1. It's not saturated. That surface area on that thing is not very good. And the concentrations are 0.12. So You will get a difference if you change all these things, but it is much, much smaller. You will be able to get an experimentally calculatable difference by changing those things, but they're not really significant.